Today you're going to learn about atomic mass. Atomic mass is based on the carbon-12 atom. If you look at a carbon-12 atom, it weighs 1.992 times 10 to the negative 23rd grams. Now, instead of measuring in grams with these big numbers like this, scientists have come up with a new unit. It's called the AMU. You need to make sure you understand what the AMU is. 1 AMU is 1/12 the mass of carbon-12 atom. So if I ask you what atom it's based off of, you need to be able to tell me carbon-12. It's 1/12 of the carbon-12. So an AMU for carbon-12 is 12 AMUs. Carbon-14 has 14 AMUs. Now, you're going to have to be able to calculate the atomic mass. The average atomic mass is a weighted average of all known isotopes of an element. These are the decimal numbers on the periodic table. If you're looking at the one in the classroom, it's the red ones with the decimals. If you're looking on your periodic table at home, it's just the decimal numbers at the bottom of each box. They are the average of all the isotopes. And not only is it just an average, it's based on abundance, meaning the more you have of an isotope, the more likely the mass is going to be in that area. So this is the formula. This is already in your notes. So just let me explain what's happening here. The A and the B stand for the isotopes. So in this case, looking at this equation, there's only two isotopes. That's why it says dot, dot, dot here, because however many isotopes there are, that's how many times you have to do this. So you do mass of A times the percent of A plus the mass of B times the percent of B. Now, you're not actually putting percent signs in the calculator. So you're just doing the mass of A times the percent of A plus B times B all over 100. So example, calculate the average atomic mass of oxygen if its abundance in nature is 99.76% oxygen 16, 0.04% oxygen 17, and 0.20% oxygen 18. So all you're literally going to do, this times this, plus this times that, plus this times that. So 16 times 99.76. Do not put the percent signs, you're just putting the numbers directly there. Plus 17 times 0.04 plus 18 times 0.20. All divided by 100. Plug that in the calculator, and you should get 16.0 AMU. Now you're going to do these to one decimal place, and the unit will always be AMU. If you leave that off, 1 point off. Now, this should make sense that it's 16.0, because which isotope do we have the most of? Oxygen 16. So the average atomic mass should be close to whichever one you have the most of. Obviously, the number should fall somewhere between your different isotopes. If it does not, you did something wrong. Pause the video and take a second to try the next example on your own. Okay, so you're going to do 80% times 34 plus 20% times 37. Now, before you even do the math, you should be able to estimate about where your number is going to be. Which isotope do we have the most of? Chlorine 35. Therefore, your answer should be closer to 35 than 37. So when you plug this in, you should get 35 times 80 plus 37 times 20 divided by 100. And you should have gotten 35.4 AMUs. Does this answer make sense? Yes, because it's closest to chlorine 35. Let's try another one. Chlorine's average atomic mass is approximately 8 out of every 10 atoms of chlorine 35, and 2 out of 10 are chlorine 37. For this one, you're simply going to do 35 times 8 plus 37 times 2 divided by 10. Instead of using 100 at the bottom, you're simply putting the total number at the bottom. So 8 plus 2 is 10. and you should have gotten 35.4 AMUs. Please review and make sure you understand how to do atomic mass calculation.